Alright, we're going to talk about arcs, semicircles, and central angles. A central angle for a circle is an angle with its vertex at the center, and it separates the circle into two arcs. Down here in this circle we have a central angle right here. This angle has its vertex at the center, and that angle separates the circle into this arc and this arc. So it's separating the circle into two arcs. And in every circle, the sum of the measures of the central angles is 360. All the central angles add up to 360, as long as they're not overlapping and sharing interior points. If you take all the central angles and add them up, it should be 360. So down here, if I'm naming this angle, I don't just want to name it angle E, because there's actually not just one angle at point E. There's another angle over here, even though it's larger than 180 and not what some of y'all might be accustomed to looking at. And anytime there's more than one angle at a vertex, we got to name it with three letters. So we're going to call this angle LEY or angle YEL. But that E has to be the middle letter because it is the vertex. Then we want to name the two arcs. Okay, well this was one arc right here, this arc, and the name of that arc would just be arc LY or arc YL. The order of the two letters does not matter. And then the other arc is this arc. Now if I'm just naming an arc by its two endpoints, then this arc would also be called arc LY. So we can't do it that way, that would be confusing. This would be called arc LUY. And again, we put the arc symbol over the top. You could also call it arc YUL. But the letters do need to go in the order that you would hit them as you trace the arc. So YUL or LUY, meaning that the U would have to be in the middle point. And the two endpoints of the arc do need to be the first and last letters. Now, these are two different types of arcs here. One of them is a minor arc. This one is a minor arc. Minor arcs have a measure less than 180, and it's named with only 2 points. So anytime you see an arc named with only 2 points, you know it has to be a minor arc. So if you were looking at this figure and they said arc LY, I would know it goes this way from L to Y and not this way, because if it's named by 2 points, I know it's got to be less than 180, and going this way would be too big. A major arc is an arc that has a measure greater than 180, and it has 2 endpoints and one other point between them. So anytime you have a major arc, it's going to be named with 3 points. So if you see an arc named with 3 points, first off, you can always put your pencil on the first one, go to the second and third one, and it'll trace that arc. But also, when you see 3 points, then you know it's going to be a major arc. It's going to be greater than 180. Alright, down here on this example, let's find the measure of angle PCM. Well, angle PCM is this angle right here, and it's already been labeled for us. It's 110 degrees. And central angles and their corresponding arcs are congruent in measure. So they're the same number of degrees. So right here, angle PCM, that central angle corresponds with this arc, and so the measure of arc PM is 110. There are 360 degrees in our full rotation, so there's 360 degrees rotating around this point here for the central angles, and there's 360 degrees rotating around that center point out here. So this rotation and this rotation, it's going to be the same number of degrees. Alright, the measure of arc PNM, it's this direction, and that is a major arc. It's going to be greater than 180. Well, this entire circle is 360, and it's being split into 2 parts. Those 2 parts should add up to 180, or excuse me, to 360. And so if I have 110 for one part, I can subtract and find out the measure of the other. So I know that arc PNM is 250 degrees. Alright, what kind of arc is arc PM? And how do you know? It's a minor arc, and there's two different ways I could tell you why. One is it's named with only 2 points. If it's named with 2 points, I know it's a minor arc. The other thing is we already found out its measure, it's 110, and so I know that it is less than 180 degrees. So either one of those two reasons are good reasons for me to know that it's a minor arc. Alright, so we know a minor arc is less than 180, a major arc is greater than 180. What about if it's exactly 180? Well, that would be a semicircle, half of a circle. 180 is half of 360. So anytime it's 180 degrees, you have a semicircle. And the most common ways you get a semicircle is when you draw a diameter through a circle. When you draw a diameter in on a circle, it splits it into 2 halves, or 2 semicircles. So each one is 180 degrees. So down here in example 3, it says in circle E, the measure of angle AEN is 18 degrees. Line segment JN is the diameter, and the measure of angle JES is 90 degrees. Alright, we want to find these other measures over here. So the measure of arc AN, now that arc goes with this central angle. So if this is 18 degrees, then arc AN is also 18 degrees. Okay, the measure of arc JA. Well, remember, this is a diameter, so from J around to N is 180 degrees. Well, that 180 degrees has been split into 2 parts. If one of those parts is 18, I can subtract that from 180 and find out what the other part is. It's 162. So the measure of arc JA is 162 degrees. And then the measure of arc JAS. JAS. Well, that arc JAS goes most of the way around the circle. The only part of the circle it does not include is this right here. And remember, this angle was 90 degrees. It's a right angle, so this arc would be 90. So if the whole circle is 360, and this part's the only part not included, I can just subtract that from 360. And that tells me that the measure of arc JAS is 270 degrees. Alright, let's look at example 4. It says ray FD is tangent to circle O. Based on the angle measures given, find the measure of each of the following. Well, first off, if this is tangent, and I have a radius drawn to the point of tangency, we learned that those have to be perpendicular. So there has to be a right angle created by the tangent and the radius there. The first thing we want to find is the measure of angle DOF, which is this angle right in here. Well, we have a triangle, and the 3 angles in a triangle always add up to 180 degrees. So anytime you have a right triangle, subtract 90 from 180, the 2 acute angles add up to 90. So I'm just doing 90 minus 38. And that will give me 52. So I know that the measure of angle DOF is 52 degrees. Then we want to find the measure of angle EOA right here. Well, there are 360 degrees. When you add up all the central angles, they should add up to 360. And we have every single central angle except for this one. So I'm going to add up what we have and subtract from 360, and that should tell me what's left. So we got 52, 85, 90, and 45. Those are the 4 central angles that we already have. So I add all those up. Should get 272. We subtract that from 360. And that tells me that this angle is 88 degrees. Has to be 88 so that all those central angles will add up to 360. Alright, so the measure of arc AB, well, the central angle is 45, so the arc is 45. The measure of arc BC, central angle is 90, so arc BC is 90. The measure of arc ED, well, the central angle is 52, so the arc is 52. Alright, the measure of arc AC. Now this is the first time on this example where we have to do this. But for arc AC, we are combining the 45 degrees and the 90 degrees. We're just adding those together. So 45 plus 90 is 135. And then the measure of arc AE, well, remember that central angle is 88, so the arc's 88. The measure of arc ADC. So we're going from here all the way around to here. Now we could do this a couple different ways. One, you could add 88 plus 52 plus 85. Or arc ADC is everything except for arc AC, which is something we found earlier. So we could just subtract 135 from 360. Either way, we're going to get the same answer. I'm going to do it by addition. So I'm doing 88 plus 52 plus 85. And when we add all those up, we get 225 degrees. If you had done 360 minus 135, you would get the same thing. All right, the measure of arc ACD. ACD. So from A around to C and D, we have 45 plus 90 plus 85. 45 plus 90 plus 85. And we add those up, we should get 220 degrees. And finally, the measure of arc AD. And it's got to go this direction because, remember, 2 letters, it's a minor arc. If I go this way, it's going to be bigger than 180, bigger than that half a circle. So I know it's got to go this way. 88 plus 52. And 88 plus 52 is 140. And the final example, we're mixing in some variables here. We want to know the measures of these central angles. Well, those central angles should be the same as their arcs, their intercepted arcs there. They gave us an expression for each one, and we know there are 360 degrees in a circle, so these should all add up to 360. So I'm just going to add them all together. And set it equal to 360. Oops. So I got the 3x plus 15 plus x plus 4x plus 2x plus 15. And the very next step would be combine like terms. How many x's do we have? 3 plus 1 is 4, plus 4 more is 8. 8 plus 2 is 10. We got 10 x's. And then the constants, we got 15 and 15, which is 30. Now, some people like to go ahead and just jump straight to that. We know we're going to combine like terms, so if you want to just combine them as you're writing the equation, you can. 3 plus 1 is 4, plus 4 is 8, plus 2 is 10, 15 plus 15 is 30. And then you don't have to write down that extremely long equation in the first place. But let's finish solving for x. 30 was being added, so we'll do the opposite to get rid of it. We'll subtract it. X is being multiplied by 10, so we'll do the opposite. We'll divide it by 10. And that shows me what x is. Now, x is 33, so to find all of these things, I need to substitute back in. So the first one should be easy. Angle AOB, it's just x. Well, if x is 33, then that makes this 33. Okay, angle BOC is 4 times x, so 4 times 33. And when we do 4 times 33, we get 132 degrees. Angle COD, so we're doing 2 times 33 plus 15. So 66 plus 15 is 81 degrees. And the measure of angle AOD, we're doing 3 times 33 plus 15. So 3 times 33, 99. 99 plus 15 is 114. So there's all your measures. And one thing you can do at the end, just to make sure we didn't make some silly mistake along the way, these angles are supposed to add up to 360. So just check your numbers, add them all up, make sure they add up to 360. And those numbers do add up to 360.